Let's start with usability. We've continued to modernize the Creo trees, updating the layer tree, improving model tree performance, and streamlining workflows between the design tree and the quilt body evolution tree, all driven towards making users more efficient. There are many occasions when designing that you need to quickly hide or unhide components or geometry to enable you to isolate an area. However, this is typically a temporary state that you want to quickly be able to revert back to. With Creo 12, we have introduced temporary visibility states, allowing you to quickly capture a state and then return to the previous state as needed. This significantly improves overall user speed. As customers update to new versions of software, it's always a challenge to identify and learn what has changed. With Creo 12, we have introduced What's New highlighting. Any new feature, capability, or option that has been introduced will be clearly identified in the interface. Users can read the tooltip and get direct access to learn more about the capability and its usage. This enables users to more quickly get up to speed with the latest enhancements in a release. Once a user is comfortable with that enhancement, they can choose to clear the highlighting. Now, probably one of my favorite usability enhancements, though, is the introduction of feature presets. At its basic level, it's a means to change the default setting for a feature. An example, when I create an extrude feature, it always defaults to create solid geometry. If I'm a designer and mostly build surface models, then I would like to change the default extrude to create surfaces, not solid geometry. However, presets are far more than just that. They enable users to capture multiple different feature presets, simplifying and standardizing the design process. A great example of this would be holes. Maybe as a user, I only use 3 types and sizes of holes. Now I can capture all the settings for those 3 holes and be able to quickly place and reuse them with a single click. Not only for me, I can also share that with the entire organization, helping to foster greater reuse and design standardization. We've continued to expand our multi-body design capabilities. One of the primary use cases for using multi-body design is to support a master model methodology, allowing users to design a product as a single part and break it up into different bodies. This provides the freedom and flexibility to try out different ideas without burdening the business with any new business objects, at least until the design is close to completion. Once a design is finalized, you would then need to make each of those bodies a final part and business object. To streamline that process, we now provide the ability for the user to create an associate assembly structure directly from the master model part, simplifying and streamlining the design process. Many times, customers will receive supplier components as step files. That file is typically an assembly of the supplier's product. From the customer's perspective, mostly they don't want or need to manage all the individual parts of the supplier's product. They just want a single part and part number. Consequently, we now provide the ability to import a step file as a multi-body part. This creates all the parts as bodies in a single part, reducing complexity and simplifying the process. We continue to expand support for multi-body design of sheet metal components, expanding the sweep flange feature and introducing more thickness control options during conversion. We also enhanced our shrink wrap capability, providing control to the users as to whether to include construction bodies or not in a shrink wrap operation. We've continued to expand our existing feature capabilities, introducing a new fully dependent feature mirror inside sheet metal, streamlining the design process and reducing design rework. The existing sheet metal join command has also been expanded to increase usability. The join command allows the connection of multiple walls or bodies together. Previously, those needed to be touching. Now, Creo 12 will automatically extend the boundaries of the walls to intersect with each other, then join them with a bend. Many customers have been asking for optimized minimum size of their products to help with shipping and packaging logistics. As a result, we enhanced the enclosed volume feature to enable it to be placed in the footer of the model tree. This will enable the feature to always be updated with the latest information at the end of the model tree and enable customers to add it to their starting parts. This updated information can then be shared with Windchill as designated parameters, so there is always an up-to-date size information available on all parts. In Creo 11, we introduced new spot welding capabilities and workflows with the introduction of joint members. In Creo 12, we have continued to enhance this, providing richer information and control over stacking information and sequencing control. We've also improved the overall visibility of spot welds, making it easier to manage products with large numbers of spot welds. We also expanded our weld export information, now supporting groove welds as well as fillet welds, enabling streamlined processes for the creation of offline programming of welding robots. Creo 12 sees continued expansion of our surfacing tools and capabilities. The style feature has been extended. Style is what we call a super feature, a feature that contains many entities. In this case, curves, surfaces, trim operations, etc. In Creo 12, we have expanded this to now support the ability to reroute and replace entities within the super feature. This expanded capability significantly reduces the amount of time to make significant design changes with a feature. The connection handles in both style and freestyle have been modernized to align with other Creo features, such as the boundary blend tool. This improves consistency between different modeling tools. Both boundary blend and curve through point features have been significantly enhanced to improve overall smoothness and quality, enabling users to make more predictable changes. There are many cases when working on designs that a user wants to reduce the number of surface patches that make up a design. For example, when working with imported geometry, there may be many small surface patches that aren't really wanted. These patches can lead to increased complexity later in the design process. As such, we have introduced a new approximate surface feature that will allow users to replace multiple surface patches with one single approximate surface, while maintaining shape and connectivity, overall reducing the complexity of the model and speeding up the design process. Sustainability and carbon footprint reduction are at the forefront of most companies' minds. That must start at the beginning of the design process by better understanding the material usage and its impact. In an early maintenance release of Creo 12, we'll be providing a connection between Creo and Windchill to enable communication of material usage and quantities, as well as providing the ability to manage materials as an object directly in Windchill. This will facilitate the integration into lifecycle analysis tools to better evaluate environmental impacts of design decisions. We have also made significant performance improvements to the retrieval of a subset of an assembly from Windchill. With Windchill, users can define a design context, identify and select components that they want to work on or are relevant to their activity. Once that context is defined, users can now directly retrieve that subset into Creo. Creo will no longer need to retrieve the entire model to validate relationships and dependencies, but will just retrieve the data in context. This significantly reduces the retrieval time and allows users to get to the design steps quicker. Creo 12 is the third iteration of our composite design solution, and each release has got better and better. In Creo 11, we introduced the idea of zone-based plies, allowing users to quickly create composites for models with large ply counts. In Creo 12, we have extended that to now provide automatic merging of neighboring plies. If the system identifies neighboring plies that are of the same material and orientation, it will automatically merge them into a single ply. We also continue to make usability improvements to existing tools such as the transition tool, allowing users to apply transitions to multiple edges at a time. Creo 12 also sees the introduction of a laminate reference model following the same concept as a manufacturing reference model, where the design part would be inherited from the manufacturing part, such that the manufacturing changes could be applied without changing the design model. For example, a casting model is different to the finished design part. We now have the same concept for composite parts as well, allowing changes to be made to the manufacturing model without altering the design part. For example, a user could extend the boundaries of the ply to go beyond the model surfaces, so they can be then trimmed back at a later stage. Probably the biggest change we have made, though, is around the performance and robustness of creating the final solid model. Creo 12 sets a new benchmark for how fast teams can build and iterate upon composite designs without compromising the quality Creo users expect, accurately representing the final geometry considering each ply and any drop-offs. Products are becoming more complex and putting greater requirements on the electrical needs. Many products now have miles of wires routed through them. This leads to the need for different processes and more collaboration in the design process. Creo 12 applies Creo's strength in assembly design to cable harnesses. Harnesses are now assemblies inside Creo, enabling teams to use the same collaborative workflows that power Creo's assembly tools. Available in a maintenance release, this introduces new cabling management tools and updated workflows. It enables reuse of many electrical elements, such as spools, terminators, and cable ties. And this information can now be managed in Windchill, along with the ability to accurately report a full harness bill of material. We've also continued to improve our ECAD support, adding support for user-defined attributes in the IDX format, and adding support for sketch regions on an ECAD board. Moving on to simulation, we have continued to broaden and strengthen our ANSYS partnership, supporting simulation-driven design. Creo 12 sees the integration of the latest ANSYS solvers. As more customers are taking advantage of performing simulations early in the design process, we have focused on improving and standardizing the results in Creo Simulation Live and Creo ANSYS Simulation. We have added automatic contact creation in Simulation Live, reducing the amount of setup time and eliminating human error. We have also added support for bolted structures in both Creo Simulation Live and Creo ANSYS Simulation. We also continue to enrich our generative design capabilities, introducing thermal optimization support, enabling engineers to generate designs optimized to meet structural, modal, or thermal goals. Creo 12 continues to expand capabilities supporting model-based definition as more customers are looking to transform their business and realize the full value and potential of the digital thread. There is now extended support for STEP AP 242, and in an early maintenance release, we will introduce an updated 3D PDF export capability. There are many times when annotations and their semantic references are similar across models and within models. We have introduced the ability to now reuse annotation elements, irrespective of the annotation feature they reside in. This improves overall productivity and reduces the need to repetitively recreate annotations. We have also made a number of general performance improvements to combination states, supporting larger numbers of elements and eliminating unnecessary regeneration when switching between states. GD&T Advisor, as well as easy tolerance analysis, have also been updated to support additional use cases and references. Finally, on to manufacturing. As always, we continue to invest and expand our additive and subtractive manufacturing capabilities. More customers are looking to leverage additive manufacturing for building mold tools. With Creo 12, we introduce a new conformal cooling feature that will automatically create cooling channels through the mold tool that conform to the shape of the final part. This leads to more even cooling of the mold, resulting in faster production times and increased tool life. These new channels are typically produced via additive manufacturing and have control over the shape of the channel to help in the printing process. We continue to expand our support for lattice creation and optimization, with the ability to now create variable density custom lattices based upon simulation results. For subtractive manufacturing, we continue to invest in high-speed machining, introducing new capabilities to support undercut machining operations, as well as providing greater control of multi-body parts in a manufacturing assembly, overall improving productivity and efficiency for the manufacturing engineer. I hope you have enjoyed what you have seen. This was just an overview of some of the 250 plus amazing capabilities added in Creo 12 and Creo Plus, providing huge value to all our users. For more information, please visit ptc.com/Creo. I thank you for your time.